Hi guys, this is the last video for your similar figures unit. We're going to talk about embedded similar figures, meaning like there's one triangle inside the other. We talked a little bit about this one-on-one when we work in our small groups. If you haven't worked in small groups, one of the things we've done is we've said, hey, there's two triangles here, so if I cover up one, I'm going to draw it, and then I'm going to uncover it and draw the second one. So let's go ahead and do that right now for our notes here, because this is where it gets a little confusing. So this small triangle here is 80 feet, and this part is 120 feet. This is stake 3, stake 2, and stake 1. And then we have our big triangle, which we're going to draw up here. And this is stake 3. This is tree 1. And tree 2. And our lengths are 160, and it's really all we know. Okay, so what's really cool is that we can actually figure out some distances even in the real world. Like, this is how people measure a distance across the river before they put a bridge on it, because it's impossible to measure that distance in real life. We don't have a tape measure long enough to know how wide the ruler is, and we have to build a bridge, you know. So it says Darnell, Angie, and Trevor are at a park along the Red Cedar River with their class, and they decide to use similar triangles to find the distance across the river. Why they do that, I don't know, because I mean, they're just kids at a park with their class. Why would they care how long it is across the river? But maybe their teacher said, hey, you can do some extra credit and figure out that distance and whatever. But anyways, are the two triangles similar? Why or why not? So we can say that they are similar, okay? And it's because, do you see how this one has stake 3 here and this one has stake 3 here? So they share the same angle right here. And so at this point, remember the 3 things that we were looking for? It's angle, angle, side, angle, side, or side, side, side. So at this point, it's either going to be side, angle, side, or angle, angle. So let's look and see, can we find another angle that would be congruent? And the answer to that question is yes. Because if you look here, the sides of the river are parallel, okay? They're not perfectly parallel, but we can just assume that they are, okay? So the sides of the river are parallel, which means that this angle right here is going to be the same as this angle right here for corresponding angles. So now we know we've got 2 angles that are congruent. So the 2 triangles are congruent by angle, angle. And the question didn't say it didn't say are they congruent, it says which triangles are congruent. So it's these 2 that we drew, okay? Maybe we can label them triangle 1, or T1, T2, and stake 3, so S3 is similar to triangle. So it was T1, T2, and S3. So then it's stake 1, stake 2, and stake 3 by angle, angle. Okay, and we've drawn those triangles that are similar already. So now we want to know the distance across the river. We want to know from stake 1 to tree 1. Okay, so we want to know this distance right here. And can we find that distance? And the answer is yes. Okay, so right now the distance on this small triangle is going to be this little bit right here, but the distance on the big triangle is actually how much? How much is the distance on the big triangle? Well, it's x plus 120. We've done lots of problems like that already, where we had to add this little bitty piece and this little bitty piece together to get a whole part. To get the whole thing. So we'd say this distance is x plus 120. And now we can just write ratios of corresponding parts. So 160 to 80 I guess I'll have to just write small. 160 over 80 equals, and then x plus 120 over 120. Make sense? And then we're just going to cross multiply and solve. So this is 80 times x plus 120 equals, and then 160 times 120 is 19,200. So we did 80 times x plus 120 and 160 times 120. 80x plus 9,600 equals 19,200. Subtract 9,600. We get 9,600 equals 80x. Divide by 80. X equals 120. So we have now found x, which is the distance across the river. So it's 120 feet. Okay. So part C says, hey, another group of students repeats the measurement. They put their stakes in different places. So now the distance from stake 1 to stake 2 is 32 feet instead of the 80 feet that it was originally. And the distance from stake 1 to stake 3 is 30 feet instead of 120. So let's draw a separate picture. We're going to draw the same picture again. And we've got tree 1, tree 2, stake 1, stake 2, and stake 3. Okay? And we're going to label it. So it says from stake 1 to stake 2 is going to be 32 feet. And from stake 1 to stake 3 is going to be 30 feet. Do the tree distances change? Did they pull up the trees and move them? No. So the tree distance is going to be exactly the same, which is 160. And so we still have x. And so now we have the exact same problem that we had before, and we're going to set up a proportion. Remember, that second ratio, the one with the big side, is going to be those two put together. The question that it's asking is, does the second group get the same measurement for the width of the river? Okay, so I'm going to guess they're probably going to get the same measurement because the river's width doesn't change. Okay, but we'll see. So let's see what happens. So we're going to say our two triangles. We'll start with our small one. So we've got our 30 over, and then how long is this big long length? X plus 30 equals, and now we're going to say 32 over, how long is this big long length? 160. Okay, so cross multiply and solve. This is 4,800. 32x plus 32 times 30 is 960. Subtract the 960. 32x equals 3,840. And then just divide by that 32, and you get x equals 120. So naturally they got the same distance, 120 feet. Okay? That's just because the river doesn't change in size. Okay, make sure you take this one, fold it in half, and glue it on that page that I have put on your playlist. And thanks for watching. Have a good day.